Imagine this. For billions of years, our solar system has been a closed neighborhood. The sun at the center, planets moving in predictable paths, comets occasionally visiting from the distant Oort cloud. Everything familiar. Then, one day, astronomers noticed something strange. A fast-moving object entering our solar system, not orbiting the sun, not slowing down, and not belonging here. It wasn't a comet, it wasn't an asteroid. It came from another star. Its name, 3I-ATLS. And scientists are now asking a much bigger question. Not just what is it, but what can it teach us? Because this single visitor from another solar system might help humanity design the next generation of space technology, spacecraft, propulsion systems, and even interstellar travel. In 2017, astronomers discovered Oumuamua, the first known interstellar object. Then in 2019, comet Borisov followed. But 3I-ATLS is different, very different. Its trajectory is hyperbolic, meaning it is not gravitationally bound to the sun. It is literally just passing through, like a cosmic traveler crossing a highway. And here's the important part. Objects like this are ancient, older than our solar system. 3I-ATLS formed around another star, possibly billions of years before Earth even existed. That means we are not just observing a comet, we are studying material from an alien solar system. No spacecraft required. Nature delivered the sample to us. Scientists are not excited just because it's rare. They're excited because 3I-ATLS is a natural spacecraft. Think about it. It survived interstellar radiation, extreme cold near absolute zero, cosmic dust collisions, millions, maybe billions of years in deep space, yet it remained intact. This makes it incredibly valuable. Every space mission we build faces the same problems: radiation damage, material degradation, long-term structural fatigue. 3I-ATLS has already solved those problems. We just need to understand how. If we analyze its surface composition, scientists may discover materials naturally resistant to radiation, micrometeorite impacts, and temperature extremes. In other words, the perfect spacecraft shielding may already exist in nature. Here is where things become fascinating. Observations suggest 3I-ATLS is accelerating slightly, but not like a normal comet. Comets accelerate because sunlight heats ice, producing gas jets. However, data hints the acceleration might be more efficient than expected. This raises a radical idea. The object may be releasing ultralight gases like hydrogen, which produce thrust with minimal mass loss. Why does this matter? Because one of the biggest problems in space travel is fuel. Rockets today carry enormous fuel tanks. Most of the rocket's weight is propellant. But if scientists learn how 3I-ATLS naturally produces propulsion, we could design spacecraft that travel farther, use less fuel, and operate longer. Some physicists even compare this concept to solar sail or outgassing propulsion, technologies humanity is only beginning to experiment with. 3I-ATLS may already be doing it, naturally. The chemistry of 3I-ATLS could be revolutionary. Why? Because planets around other stars form under different conditions, different gravity, different radiation levels, different star temperatures. So the minerals inside 3I-ATLS may not exist anywhere in our solar system. Imagine discovering ultra-strong crystal structures, radiation-proof compounds, naturally reflective materials. These could inspire spacecraft hulls, heat shields, Mars habitats, and deep space probes. Right now, spacecraft heat shields burn up during atmospheric entry. But what if materials inside 3I-ATLS already survived extreme stellar environments? Instead of inventing from scratch, we copy nature, just like airplanes copied birds. Here is the bigger dream. Humanity wants to reach another star, but there's a problem. The nearest star system, Alpha Centauri, is 4.3 light-years away. With current technology, it would take over 70,000 years, impossible for human exploration, unless we learn from interstellar travelers. 3I-ATLS proves something crucial. Objects can naturally travel between stars, so the universe already has a transportation method. We just don't understand it yet. If scientists decode its structure, its propulsion, and its thermal properties, we may create the first true interstellar probe, a spacecraft that doesn't just orbit planets, but visits other solar systems. 3I-ATLS may look like a simple rock, but it is actually a messenger, a piece of another world. It tells us the solar system is not isolated. We are part of a cosmic network. And the future of space exploration might not come from laboratories, but from studying what the universe has already built. Every major human invention began the same way. We observed nature, then we copied it. Birds to airplanes, fish to submarines, and perhaps 3I-ATLS to interstellar spacecraft. This object will leave our solar system soon. We may never see it again, but the knowledge it carries could stay with humanity forever, because the next spacecraft humanity launches might be inspired by a visitor that traveled across the galaxy just to pass by our sun, and in doing so, it may have shown us how to reach the stars.